I'll keep an eye on the admissions and try to make sure folks get in. I don't know why that's happening, so apologies about that. But welcome to the Istio contributor workshop. This is a one-off event. I started talking to a couple of different people who described wanting to get to understand KRT a little bit better. And so we were able to get this scheduled to set some time to discuss it. So how this is going to work is, let me go and find the presentation. I made a quick PowerPoint just to give a high-level introduction of KRT and its role in Istio for folks who aren't as familiar. And then we are going to, and then we're going to discuss, are going to go through some examples of KRT that I made with, I've live coded some examples showing all the different KRT features. Interesting thing, disclaimer that I will give as we're getting things started. For some reason, apparently I made some changes and now the demos don't work anymore. So that's super lovely. Oh, and I think I see why it is. Okay, so we'll talk through the process of a lot of the code, but some of the things aren't going to work because they're using static collections instead of informer-based things. So we'll go through all of this when we look at the examples. But first off, let me bring up the PowerPoint and share my screen. Oh, and before I share my screen, I want to, there's actually some notes that are attached to the meeting. I will share them here, and then I will bring them up so that folks can see what it looks like when I share my screen. So I'm going to go share this window. Okay, so this is the notes page. Again, I put the link in the description, and everybody in the Istio group should be able to edit it if you need edit access. Actually, everybody should have comment access. Give you that, Ricardo, and share that. But essentially, I want to set this up to where anybody with the link can be able to comment. So please add your name as an attendee just so we can see if this is something that people would like to do more frequently and things like that. And if you want more of these sessions, please put potential topics here in the action items section. I've also linked the PowerPoint and the demo repo so that we can get it so people can follow along afterwards. Okay, all of that housekeeping stuff out of the way. Let's actually look at the presentation. So this is obviously talking about KRT, which, if you aren't familiar, it's Istio's declarative controller framework. Yeah, because the formatting got messed up. Okay, why does KRT exist? So for some backstory, KRT was something that John Howard built in 2023. Yeah, 2020. Yeah, early 2023, in order to solve some of the challenges with controllers that we were seeing within Istio. So typical controllers have, the developer, the author of the controller, and the people who come afterward have to manage event handling. They have to manage doing caching to make sure the performance isn't horrible. Have to do reconciliation just right. There's all this extra stuff about writing a controller loop in Kubernetes that you have to deal with if you want to be effective. This can be really error prone, especially for us as an open source community within Istio. We want it to be a little bit easier for folks to be able to come into the project and become productive. And so KRT addresses some of this by putting all of the synchronization and reconciliation behind a framework. Istio actually has multiple controller primitives already. There is a kube client, which takes care of informer factory things and make sure memory and lifecycle things work as we might expect. And then there is K client, which is built on top of the kube client, so that users can create these new informers fairly easily. But what KRT does is that yet another layer on top of K-client to allow you to essentially declare your control over declarative intent. So basically with KRT, you talk about what inputs you want to base your data structure off of, and then a transformation function to map your input type to your output type, and KRT kind of does the rest. This makes it a lot more readable, and a lot of the complexity is hidden from the common developer. Collections are the core abstraction in KRT. A collection is not bound to informers or anything like that. It's just a set of objects that have a stable identity, and that those objects change over time. So, for example, Istio uses reads mesh config as part of its mesh, and that can come from a file or a config map or things like that. And so you can create a collection of just mesh config from any one of those sources. I heard a question. Yeah, hand.
Yeah, quick one. What do you mean stable identity?
Great question. So everything in a KRT collection, each element needs to be able to have what's called a key. And that key is what identifies that object in the collection throughout that entire collection's lifetime. That key also is responsible for setting up relationships between the input data structure and the output data structure. So, for example, if I have a input of a bunch of pods, and I want to take the IPs, create a collection of IPs out of that set of pods, then KRT knows all the different keys, and I think the keys for pod is basically namespace in name. KRT will know what all those keys are, and then for every IP output that comes out of in the output collection, KRT creates this relationship between that input key and the output key, so that the output collection is only recomputed once that input key changes. So it's an efficient way to prevent having to recompute the entire output collection when any one of the input collection changes. The key is how you make sure that only the only thing that gets recomputed is the outputs that are dependent upon the input key. Does that help? Does that make sense?
Yeah, thanks.
Cool. Yes, sorry about the access for the sheet. I'm looking to try to see how I can add, oh, here we go. Anyone with the link can, at the very least, comment. There we go. So that should fix the access problems on the doc. So please refresh and try again, and folks should be able to comment on this. And then folks who are Istio community members who should have a bit more access, maybe. Actually, can I'll just say edit. It's a one-off meeting. It's fine. Everybody can edit. There you go. So now you can accept your own comments. All right. So yeah, add your name and company as an attendee, and then if you've got any ideas for future sessions, please add it there below. Okay, so back to collections. So collections utilize Go generics very heavily. So it's this very uniform interface where you can declare with Go's generic type system the exact types that you're moving from and to. This gives you a consistent interface, like the collections interface on top of two generic types. And so regardless of what you're transforming to or from, you can express that generally with KRT collections. Collections generally, it says immutable, and that's from a memory perspective. So collections, you don't change what it points to, but the elements within a collection can absolutely change. This actually helps break down some of the common memory and race condition issues that you can run across in sort of quote unquote manual controllers. If memory access changes, as long as you've got a reference to a collection, that should remain stable throughout the lifetime. Talked through it already. I'm going to try to get through this somewhat quickly so we can get to some of the demos. Lior's question touched on this a little bit, but keys are very important within KRT. Stable keys allow us to be able to identify one element for another, and it also helps us to, for some of the hot hot path operations, you don't have to do a deep equals on every single element check to see if it changed or things like that. We can or to set up relationships. We can just check the key of the data, and this helps us to track it across as that element propagates throughout the framework. If you have unstable keys, and we've actually run across a couple of bugs with this, sometimes you can set things up in such a way where the key that you have might change throughout the lifetime of a collection. That is no bueno. And so ideally you want to encode enough information in the key when you're making your collection so that that key remains stable and immutable throughout the lifetime of the object. A good example that comes to my mind here is when we are translating from services and service entries in Istio. For those of you who might not know, in Istio's core sort of registry logic, service entries and Kubernetes services translate to the same core data type. This is true within ambient and it's true within sidecar. If you get into a situation with KRT collections where the key that you choose for the service type and the service entry, where the key you choose for the common type can actually create overlaps depending on if it's a service that created it or a service entry that created it, you can get into some really weird state bugs where a service might disappear from Istio service entry, or some of the properties of that service can change seemingly randomly because a service entry might overwrite it or things like that. So having a stable key and encoding the right values is really important. What we do in this particular case is we actually encode the kind that originated that internal service representation inside the key, so that we can keep services and service entries separate and reason about them in separate ways and do merging manually the way that with the semantics that we want. I'm going to pause here. I'm going kind of quick. Does anybody have any questions about what we've talked about so far?
Are collections exclusively like kube or Istio, things that eventually end up as custom resources, or are they like logical intermediate steps? Maybe like with the services and service entry example, would a collection then also be the merged type?
Yes. So there is no constraint on. So again, a collection is an interface that's generic over one or more types, and there's no constraint on those types. It's a type any. So there's nothing in the framework that has to do with CRDs or kube. It's a generic framework for handling Go types and Go objects. So we have intermediate representations that are in KRT collections. We've got file. You can have file handlers that are in KRT collections. You can have pretty much anything you want within a KRT collection, as long as you can uniquely key it. That's the real constraint. There's you need to be able to have a key in such a way that that key is unique within the set. Naranjan.
By element here, do you mean like a specific resource that Istio is watching for?
I just mean a member of the collection. So it doesn't have to be a Kubernetes custom resource. It's just when you create a collection, you can think about it as an array, and the element is just defined within that array. So any member of a KRT collection is an element. Any other questions?
So I guess in theory, you could have like effectively I don't know why you would do this, but a cloud provider resource that represents a collection, right? Like if you were looking at, I don't know, I've looked at this before. So like Cloud Map in AWS, which is like a service registry, you could have that as a collection if you were implementing your own custom plugin or logic or that type of thing, right?
Right, absolutely. And as we'll see later, KRT actually has a way of bringing in state from outside of KRT. So we'll see this in the demo. The constructor for a KRT collection, you take in a collection typically. So a basic new collection has an input collection and then and creates an output collection from a transformation function you provide it. How do you then get something that's not inside of KRT, like a cloud provider resource? How do you get that into KRT? There's a way to do that within the framework as well. So you can, there are things you can do in order to make that a reality. But yeah, it's a very common pattern. You can make a collection of pretty much anything. Okay, transformation functions. Want to talk about those. So as we mentioned, the constructor, the signature for pretty much every KRT collection almost always has this transformation function that is a part of it. So what do you mean by transformation function? A transformation function is a function in Go that is generic across two types. Yeah, always two types. The type is the type of the input, and then the one type's the type of the input, the other type's the type of the output. These should be pure functions, so no side effects. Sometimes you might pull from outside states, though you typically shouldn't in most of the common paths. Again, we'll get to some of the details there in a second. But by declaring things like this, you get this pipeline architecture where changes in one collection can propagate all throughout the controller, all throughout the stack, and it's a really reactive type of experience. If any of you folks have used React before, it's somewhat similar to the React diffing mechanism. In the same way that you've got one React component that might have a change, and then all the components get re-rendered. Lior, go ahead.
So you said like always two types. Do you necessarily mean Kubernetes types, or I can have a transformation from one collection to another collection? Like, right, because a collection doesn't necessarily have to produce a Kubernetes thing, right?
Right. Yes. So again, this is none of what I'm talking about is specific to Kubernetes types. Everything here is implemented just in Go types. There are some convenience sort of KRT helper functions for Kubernetes use cases. Routing to status is one of the big examples here. Everything here is just a Go struct. You can create a collection from one type to another type, and as long as those types have that unique key, as long as they have a equality, if you can use deep equal on them, or you can provide your own equality function via an equaler interface that KRT implements. As long as you've got those two things, unique keys, and then equality, you can create a KRT collection out of it.
Okay.
Okay. And then one last thing, comparing it to traditional patterns, we already talked about this a little bit, but client Go, controller runtime, all of these are great for their use cases. I've used, I don't think I've actually used controller runtime, but I've used client Go a good bit, and like they all have these reconciliation loops, they respond to and delete and update events. And when you're getting started writing a Kubernetes controller, this is what you're used to. And it works fine. But again, for Istio's use cases where we've got a lot of state, like Istio, I think, has anywhere from 20 to 30 Kubernetes controllers that's reading things in the cluster, writing state, programming envoy proxies, programming other proxies. With all those different controllers and the different inputs and different dependencies between all those different states, something more, how should I say, a more robust framework sort of emerged to be necessary, so that you don't have to become this Istio expert to be productive within Istio. And so everything that KRT does is relationship based. You have a relationship between your input and your output, relationships between other dependencies that might live in other collections, etc. Lior, go ahead.
Sorry to got you. So just a quick question to make sure I fully understand. So the reconcile, traditional way, like loop. So where would it be implemented in KRT? Is it like in the transformation function?
Yes, KRT internal. Within the KRT package itself, there is logic that handles, okay, what do you do when this thing changed? How do you parse whether or not this was an add or an update or a delete? What events do you send out to different collections? The relationship stuff all happens in the internals. Like all that gets sort of done once within KRT, so that the actual person writing the controller author, doesn't have to keep track of that. The idea is that as long as you follow certain constraints as far as how you build your collections, then KRT will do all of that stuff for you.
But where's the logic? Like, say I have a traditional reconcile loop that reads, pods and, do whatever, right? Like, where is the logic is going to be written? Like, is it going to be written in that transformation function? Like,
yes.
Would I have a KRT helper to say, listen to this, hooks and do X?
So KRT has some convenient things to be able to create collections from existing Kubernetes things. So if you have a Kubernetes informer in Istio's kclant library, you can wrap that informer and turn it into a KRT collection. There's a happy path for the common sort of informer cases. And then from there, it's all KRT. With that like pods and services example, you just write a transformation function, taking that pod, turning it into whatever you want to turn it into. And KRT takes care of reading from the informer updates and running a transformation function, doing a diff to make sure that the output didn't change from one to the other. And then if it did not change, then it won't send an event. If it did change, it does send an event. And then it cascades down. If that output is an input to a different collection, it pipelines all the way through. Jiwei, go ahead. Oh, yeah, no problem. Jiwei, go ahead.
Keith, can you hear me?
Yes, I can.
Okay, yeah, I joined twice. Anyway, I have a question about the collection. So as you just mentioned, there will be a phase function, a function needed, right, to transfer from the input to output. So I just wonder, are there any any way to like bypass this function? So in my case, input and output are the same. So I just doing the same thing, right? I just create a new object to point it to the old one. Is it something like that?
So if you're not changing anything about the data, you don't really need a new collection, right? Collections are about transforming from one thing to another. You can have a collection from one type to the same type, but there should be some modification of some sorts happening in that transformation function. Otherwise, you need to reuse. You should just reuse the initial collection. Does that make sense?
Yeah, a follow-up question. What if I don't have initial collection? So I can just create initial collection without transform, right?
Yes. So that's where static collections come from, or like singleton collections. Those are just you set the state initially, and then it gets updated throughout. That's also where there's a thing called there's a KRT function called new from nothing that we're going to talk about, where you can actually create a collection by sort of bringing out by leveraging existing state somewhere else. So if you've got an array somewhere, or something like that, then you can create a transformation function that's going to read external state and reset the contents of that collection. We'll talk about that in just a little bit.
Cool. Thank you.
No problem. And then I'll go ahead and end and finish this PowerPoint off. I added some resources here, links to KRT README, as well as the KRT KubeCon talk that John did in 2023. This is the KRT demos repo that I vibe coded. We're going to be talking about looking through that in a little bit. My AI found the original KRT design doc, which I don't think I've ever seen, and that has some cool historical context in some of the comments there. And then lastly, one thing that folks might be interested about if you want KRT's goodness on other non-Istio projects, a community member has been working on extracting KRT from Istio and has a pretty good sort of alpha proof of concept of what that could look like. KRT within Istio is very coupled to Istio's needs and uses Istio's existing frameworks. For folks who don't want to bring in the entire Istio dependency into their project to use KRT, you might be interested in this KRT Lite project and working with this community member. Okay, that's about half of our time. I want to spend the second half looking at some of the samples. And apologies because of some of the KRT quirks. These aren't going to actually run. Funny enough, or they'll run, but they're not going to work the way that we expect. But I think they're still informative for stepping through. So let me first explain how this repository is organized. Like I said, this was vibe coded, and the idea here is to give people sort of basic examples of how KRT can be used. These don't require a Kubernetes cluster to talk to, or don't require you to create any sort of state outside of the Go program. And it shows off 7 of sort of the core KRT features, so to speak. One-to-one collections, one-to-many collections, how to do collection dependency management, indexes, event handling, many from nothing, and join collections is where we start. I see your question, Liam. So there are a couple of things about pronunciation, a couple of different ones that are floating out there. I say KRT just because it's easier for me. I know some folks say cart because it's like KRT, so cart. Have not heard carrot, but I think there might be an argument to be made for that. Yeah, whatever folks are, whatever folks like, we generally know what you're talking about. But one of the things I was very specific about telling my Copilot to do was in each one of these folders, like each example is divided into folders. Each folder has a README that talks through the KRT feature. I spot checked them, and I'm pretty sure most of them are accurate. I've edited them where I've needed to. And it also talks about when to use that KRT feature. And then the thing I think is most helpful is all of them link to an example in the Istio code base that utilizes that feature. So if you want to use, if you want to see how new collection might be used, it's used at a ton of places, but one in particular place is the gateway controller. So you can actually see how we within Istio are using some of these features, and that's super useful with some of the advanced features. So let's get started looking at some of the code. So here is a typical pod. This represents a Kubernetes pod. Again, we're not connecting to a Kubernetes control plane, so there's no informers, but you can imagine this coming from an informer. This resource name type is actually here to fulfill a KRT interface. So KRT needs to figure out an ID. The first thing we'll try to do is to see if it implements this resource namer interface. And if it does, then whatever this function returns will be the key of that object, the key of that type, in whatever collection that type is used from. So if I put this pod type, if I used it in 50 different collections, all 50 of them will be using this resource name function to determine the key of that type. In this case, it's the namespace with a slash and then the name of the resource. And then similarly, there's the equals function to compare whether or not they're equal. It's easy here within this basic example because, you know, this pod only has a few fields, but as probably most of the folks here are aware, the Kubernetes pod spec is absolutely massive. We don't actually care about all of, we might not always care, usually don't care in Istio about, for example, the last applied annotation of a pod when it comes to comparing equality. So we can provide a custom equality. Oh, go ahead, Liam.
Does equals here mean equal potentially the same object but differences over time? So say if something, actually I guess with pod it's kind of weird because you're gonna get a new pod name, but like if it was a service and I don't know, maybe someone added an annotation, right? Are those, would you consider, is it potentially the same resource, or is it purely just key? Because this one's basically just key, right?
So this one's not quite key because the key here comes from resource name. And so like node name is not in the resource name, so it's not key equality. In the example that you were talking about with service, this is why I talked about picking your key is important, picking your equality is also important. So when you create a new type and you want to use that type in a KRT collection, or even you're using an existing type, you want to use that type in the KRT collection, you need to think about, okay, how does my controller, and really all the controllers using this type, what do they rely on? Sometimes it's necessary to create a separate type per package, which is actually more along the lines of Go best practices. But sometimes you might want to create a separate type per package that just maybe embeds that other type and have a different equals operation depending on how one particular controller uses it versus another. If service annotations really do matter to you, then you might want to take into account the different annotations and say, oh, this service is not equal if the annotations change. And I know, for example, in Istio, we do consider annotations to be a change for a service because annotations on services change a lot of different behavior. And
Okay.
so, yeah, long answer, but hopefully that helps.
Yep.
Leroy, you had a question, I think? You had a hand?
Yeah, I mean, just a quick one. Like, would you be able to quickly do, like, so say it wasn't a real example, like, would you really have the type pod struct here as well, or would you use the regular pod struct?
Use the regular pod struct. So like most of the time in Istio, and I can find links later, or actually the READMEs have links. You'll see like core v1.pod. Like that's the actual type of the collections that we use. And then we turn those into an internal part of internal sort of representation. And we turn those into any number of things based on the collection output functions or output, the transformation functions. That's what I'm trying to say.
So basically the equals here, like, is just a way to know when to trigger an event, right? Like, this is mainly like if something has changed, right?
That's one of the primary uses. The other one is event handling. No, keys are used for deduping. So yeah, I think event handling is the primary one for equals.
Yeah. Okay. Thanks.
No problem. Liam, another good question. So for the Kubernetes types and for like CRD types, Istio's KRT or the KRT library actually has some other things it tries before it does the like reflects deep equal. It uses proto equality as well. So for like all the Kubernetes types and for the Istio types, there are protobuf messages for them, and so we can use the proto equality in order to be able to check whether it's equal or not. And I think there's a similar thing for like the namespace name. There are a couple of sort of common cases that KRT uses for Kubernetes types, and that's one of them. So you don't have to actually embed the core v1 type or create your separate type, your own personal type, if you're using a KRT. Generally, it can be less efficient depending on the scope of your controller. You can always embed and override the resource name. That's totally an option. The other thing that I would say is that you don't know about how efficient it's going to be over time. So maybe for the first controller that you write within your application, you only care about a couple of fields. But if you add a new controller and you suddenly start needing to have access to other fields, or other fields start changing the equality logic, then you're going to want to have access to those as well. And so sometimes having the core type might be a little inefficient on the front end, but if you're like Istio and you've got 40 different controllers, different, slightly different use cases, doing slightly different things, it's just better for us complexity-wise to keep to keep track of, to have them all be the same original thing. And yes, controllers, when you think about Kubernetes controllers, I'm talking about things that like write to some state somewhere. And so you can have sort of the same input collection being used into different Kubernetes controllers. They're all informers. So if you're using informer factories, they're not going to be like, the informers aren't going to be copied, but the state inside the collection itself might be copied. So there's some nuance there. I can follow up with anybody who's got questions. Before I forget that, I want to call that out. If you've got questions about KRT and certain use cases, or if you're working on something in Istio and need some help, come into Istio Slack, the contributors channel, the ambient dev channel, and the contributors and ambient dev are sort of the two big places for getting help in these questions answered. So happy to follow up offline with any outstanding KRT questions. Okay, so in this example, we talked through resource name and equals. Simple pod is the output type, and so you see we're stripping out a couple of things like labels, labels, and node name. So very common if we're writing a controller, we know it's going to be the only one we ever write, and we don't care about labels or node, you might strip these things out. So this type has its resource name and equals as well. And here's what, this is why the demo doesn't quite work. So we create the static collection here. And oh no, that's why it doesn't work. that's nil. This should be bells synced. Interesting. Okay, I'll have to take a look at that later. But you can imagine this is an informer. Again, we're singling that informer thing here. We don't want to have to. I didn't want to have to require people to have a K8s cluster. But you create your initial input collection from somewhere. In this case, a static collection where you just sort of create the collection initially. And then here's the magic, this KRT new collection. You can see the two types here. This is input type, output type. You pass in the input collection, and then you've got a transformation function that takes this pod and returns a simple pod. That's what I want to go to for this one. Any questions on this basic flow? Okay, so yeah, so this is the basic flow here. You've got this collection of pods. The transformation function gives you one pod, and all the function has to do is return a one pod back. Very simple one-to-one relationship. But there are more common or more complex scenarios, for example, and that's where you've got one-to-many relationships. So in this case, and I'll go to the README here, you're going to go to the krt.newMany collection, and that creates a transformation from one thing to many things. Looking at the code and how that looks. So in this case, you've got a Kubernetes service that has a list of ports. And then you've got this service port, which is going to be our output type, which is going to be associate a service and some service information with its port name, protocol, and number. So here again, we sort of create our simulated collection that is a collection of services. And then we use this new mini collection and similarly pass in that initial services collection. This is our transformation function. The difference here is that instead of taking in one service and sitting out a service port, we're taking in one service and sitting out a list of service ports. So again, one-to-many relationship. So we go through all the service ports, keep the service name in each service port, but add the per port details. And the result is a slice of service ports, or a slice of the output type. And then KRT is responsible for joining all those together into one collection that you can query. So one-to-many relationship. Any questions on that?
Would you always start with static collection? No, I remember there was some new collection, not static collection, right?
Yes, again, we're simulating a Kubernetes informer here because that's going to be the common case. You can use static collection if you would like. Yeah.
Not sure I understand the answer. So like, there is a new collection as well, right? So what's the difference between your static collection and a new collection?
So a new collection requires you to actually have an input collection to pass in. A new collection requires a dependency to be created between an input collection and output collection. So if you don't have the static collection first, you don't have any input collection to create your output collection. So static collection gives us that initial state the same way that an informer would.
Okay.
So
Okay.
when you say that Istio has 40 plus controllers, is it really the collection? And that's how you're defining a controller?
No, I mean like 30 to 40 actual, maybe it's like 20, I forget the exact number, but yeah, 22 to 30, maybe 40 different classic Kubernetes controller loops where it's reading, it's got a distinct job. It's reading that state and then pushing it somewhere inside the application. Like, you should really think of Istio instead of being one monolith. It started off as a bunch of like 4 different microservices, and it's evolved over time. So we've got a separate controller for handling ingress resources. You've got a different controller for handling, by handling ingress resources, what I mean is that controller actually reads Kubernetes ingress resources with an Istio ingress class name and translates those into internal representations and adds that to sort of the general state structure that exists within Istio. So what that means is when when the user is using Istio ingress, not many do, but they do exist. The actual Istio-D logic reads Istio virtual service, an Istio gateway, and all those sorts of things. That's one controller. You've got a separate controller for doing that same thing for gateway API. Got another controller for reading multi-cluster remote secrets. You've got another controller for creating ambient things. Another controller for doing generating XCS configuration. Another controller kind of for actually pushing XCS. So all of those are sort of distinct controller loops that are responsible for some subset of functionality that makes Istio function. And there's a lot of them. 40 might be pushing it. I think 22 is the last one that I saw, and there's been a couple added since. So maybe 25 to 30 different controllers.
I gotcha. So within those controllers, you could have many different collections that are being acted upon all within the same controller.
Yes, exactly. Each controller can have one or more KRT collections. And not every one of those controllers are using KRT. KRT is a really new thing, and like maybe 15 of those 25 to 30 controllers existed before it. There are some efforts to try to migrate controllers to KRT, but for some of the ones that have been powering Istio for a long time, it's sort of risky. But we are making some progress. There's one community member in particular doing a great job converting sort of the classic K client controllers into KRT. Ricardo, go ahead.
Yeah, so one thing that I can see, the functions, they never return an error. So is there a situation where KRT needs to deal with some sort of error internally, and how it deals that?
Great question. So error handling is, and error propagation specifically, is one of the trade-offs of KRT. So because there is no error function or error returning KRT, nothing's going to like stop processing, and that's sort of by design. Nothing stops the collection as a whole from processing. What you can do, however, and I call this out on which one? It's called, yeah, okay, I missed it. So if you notice, one of the arguments we talked about here is the input type, but there's also this KRT handler context, and that's sort of how a transformation function can interact with the KRT state machine, so to speak. And that handler context has this function called discard result, which is a way to essentially ignore that event and tell KRT, hey, go back to the current state if there is something wrong. And so we use this a lot. For example, if someone, you've got a working mesh config, and then somebody changes mesh config to where it's invalid. They added a tab character and YAML hates tabs, or they indented something wrong, and we can't parse the mesh config. What we'll do is we'll call discard result, which essentially says, ignore this change completely, go back to the last known good state. You'll want to log to make sure that there is some record of the change being broken. You might also, for certain things, emit a metric or change a metric within Istio for people to track it. But by and large, logging and then discarding the result, or if that change is invalid and you want it to sort of be nil, you can clear it from the collection, clear that element from the collection by returning nil. So those are the sort of two ways you handle errors or some bad state within KRT.
Okay, thanks.
Cool. Question: any filters on the input collection? So that sort of goes to what I said previously. So if, for example, you only want to create a collection of pods that start with the letter A. It's in your transformation function. If you actually, I'll go back to the code here because it'll be simpler. Let's say that this simple pod output collection that I'm building here with new collection. Let's say I only want pods that start with the letter A. So if I get this pod, what I can do is say if strings.starts begins with, of course, live coding is hard. Prefix has prefix. If strings that has prefix A, if it starts with letter A, or actually I want to say if it does not start with the letter A, then return no. And yeah, everybody knows what I'm trying to do. Oh, and then pod dot name. Yeah. So if there's a pod that doesn't start with the letter A, then it won't be in our initial collection. That's how we sort of do that filtering logic. Okay, moving right along. One of the interesting things, and actually the thing that spurred this entire workshop, is around collection dependencies. So there's this public function in KRT called fetch. And fetch is really what makes KRT so special. It's a reactive. Oh, go ahead.
One second. Can you go back to show me where did you do the A filtering? Starts with letter A.
I moved it. Sorry. It's just this right here. So as I'm running my transformation function, as I get a pod, I check the name. It doesn't start with A, I return nil.
Yep.
That'll make sure that the resulting collection only has simple pods whose name starts with the letter A.
I appreciate it. Okay, thanks.
No problem.
But that's only the output collection, right? The simple pod collection. Yeah.
Yes. So the initial collection stays the same. Like the transformation function should never. This is actually a really important point. The transformation function should never ever modify the contents of the input collection, and in fact, that's why this only returns a pointer. Now, it does not have a pointer type. Now, if you're, for example, working with Kubernetes types, you've got like a 4v1.pod, the contents of those collections are actually pointers themselves. So you have to be very careful to not modify, similar to Kate's informers. You don't modify the type coming from the informer. You don't modify the types in the input collection either. That's a very critical thing to keep in mind. Okay, really quickly, dependencies. So fetch, like I said, is what the secret sauce of KRT. When you call KRT.fetch within a transformation function, you pass in that handler context we talked about. And by passing that handler context, the fetch function actually creates a relationship between the input key and, three things actually: the input key, the output key, and the thing that you are fetching from. So KRT fetch allows you to sort of bring in information from other collections. It not only queries that function, like on the first iteration of the transformation function, for state to be able to use it in transforming and creating the output type, it actually registers that dependency. So anytime that other collection changes, and specifically anytime that other collections, anytime that key that you depended on from the other collection changes, that transformation function will be rerun for that key again. So it's an efficient way to do dependency management within collections of different types. There are filters available for fetch. You can filter, fetch something by its exact key, fetch it by a namespace name, fetch objects matching a particular label, selector matches a label. We can filter from an index. We'll talk about that. That's a separate folder here, or just an arbitrary filter function. And those are all ways of fetching. One thing I keep forgetting to mention, KRT transformation functions can be called one or more times. So they should also be written to be idempotent as much as possible. KRT might run it twice in some cases. So in general, you should not assume that your function will be only run once. So as we talk about here, instead of manually wiring up event handlers between one collection and another collection, by using fetch, you're actually able to subscribe to changes from other collections within transformation functions in an efficient way. This is actually the root cause behind a backend TLS policy bug that Ricardo was facing down. The issue there is that the code was using a get by key query within a transformation function. You can query collections, with get by key or list to see what's inside of them, but get by key and list do not subscribe to updates. So the easy fix there, I think Stephen Landau put a PR out this morning. The easy fix there is just to change to use KRT.fetch instead. So that way, I think the bug was that whenever the config map reference from backend TLS policy changed, that backend TLS policy status was not updated. And so when we use fetch, then the controller, the KRT transformation function is actually able to see that there is a change and then propagate that throughout the system. And so to see what that looks like really quickly, in this setup, we've got a Kubernetes service. We've got endpoints representing pods backing this service, and then a output type that has a service with endpoints. And so we're creating two collections, again, simulating case informers, one for services, one for endpoints. And then we're going to create a new collection from service, service being the primary collection, and it's going to spit out service with endpoints. And so the first thing that we do is we match, skip the whole sentence in my mind. The first thing that we do is we call character.fetch. We're going to fetch from the endpoints collection, and for this particular service, and we only want those endpoints that match the services selector. So again, cool thing about fetch, it's not creating a dependency between collections. It's actually creating dependencies between different keys in different collections. So if a endpoint gets added to this endpoints collection and that endpoint does not match the services selector, this service will not be recomputed. We don't do any wasted work there, which is why filtering and having proper indexes is really important with KRT. But after we get the matching endpoints, then we sort of build out the service with endpoint struct like normal. Okay. I'm going to skip indexes just for time's sake, but the thing I really want to get to is event handling. Event handling in KRT looks very similar to subscribing to events in Kubernetes informers. So here we create a collection from routes to route config, and then we can use KRT.register to create the event handler. What this does, pausing for a water break. Okay, what this does is register adds an event watcher to the collection. So anytime an item changes, that handler is going to be called. One of the interesting things to know about how register works is that every register call spawns its own Go routine, at least today. That's how it works today. What this means is that you don't have any head of line blocking whenever you're creating event handlers. So let's say you've got one event handler that is super quick, is done in 3 milliseconds. But you've got another event handler that we take some action, but it needs a network call, and that's going to be about 500 milliseconds for some reason. Because KRT has separate Go routines for all the events per event handler, that long network handler call does not actually hold up that 3 to 5 millisecond event handler call. So you don't have to be too worried about any head of line blocking when setting up event handlers. Register is sort of one of the main functions here, where you just get an event. That event has 3 different kinds of events: add, update, and delete. And you can do whatever you want based on those events. And you've got access to the within the event, you have access to the old thing and a new thing. We also have a variant on register called register batch that allows you to not run with the current state. So by default, if you've got, thinking about informers, if you've got events that have been lining up, excuse me, that's not the right scenario. When you start an informer and things are syncing, once everything is synced and you're ready to go, you might, register by default will send events for the existing state of that collection. If you don't want that, you can do register batch, you can pass through false, and now you'll only get events for the new events that happened since the collection is synced. And then with register batch, you also get a list of events where you can potentially batch things or make things more efficient. So that is time. That's all the time we've got for today. But this entire repo is on GitHub. I'm going to try to see if I can figure out how to actually make the examples run like I expect the static collections. There's probably something simple I'm missing. But hopefully this was helpful and informative to you. Again, if you've got any ideas for future workshops that might help you contribute to Istio, or just questions you've had about the Istio code base, please feel free to reach out to me or to TOC Steering Questions in Istio Slack. We'd love to be able to help folks contribute to the project. Oh yeah, and if there's any KRT questions, please bring those to Istio Slack as well. Take care, everybody. Hope this was helpful. Bye.
Thanks. Bye.